In this video tutorial, we will see how we can run Llama 2 in Google Colab with LangChain. LangChain is a framework for developing applications powered by large language models. For example, if you want to build your own chatbot application based on your own data, then LangChain framework is perfect for you. But there are a lot of things that we can do with LangChain. We'll cover them all in this video tutorial. So in this video tutorial, we will first go through the installation step, and then we will load the Llama 2 model. After this, I will just go to the prompt templates. In prompt templates, we will learn what are prompt templates, why we need them, and how we can easily create our own prompt templates. Then after this, I will go towards the chains. Chains are, you can say chain are sequence of calls, or using chains, we can combine multiple prompt templates. Okay, we will learn about sequential chain. We will also learn about simple sequential chain. We will see what are the drawbacks of simple sequential chain and then why we need sequential chains. So after this, I will go towards the memory. If you have used ChatGPT or any Llama 2.ai model, so you should know that it remembers the past information. Okay, so we will see how we can add memory to our large language model in this Google Colab. After this, I will also discuss about document loaders. We will see how we can load a PDF file, how we can load a CSV file, how we can load a text file, and how we can extract the data from the CSV file, PDF file, or .text file. So this is an overview what we will cover in this tutorial. So let's get started with the installation of the required packages. So here I have listed all the required packages that we are going to install. So I will be installing transformers, I will install LangChain and bits and bytes package. So I will just run this and install these packages. So from here, let me just show you. In this tutorial, I have just selected hardware accelerator as GPUs. Okay. So now I'm just installing all these packages. Okay. So in this tutorial, I will be using the Llama 2 chat model available on Hugging Face. So if you have just checked out the repository, we just remove this and then click on enter and then go to the first link from here. So here is the all details about the Llama 2 is provided. We are unlocking the power of large language models, and here you can just go towards all the details. So Llama 2 comes with 3 different models, which includes one model is with 7 billion parameters. The second one is with 13 billion parameters. And the third one is with 70 billion parameters. And also Llama 2 comes with pre-trained as well as fine-tuned chat models, which details are given over here. So the Llama 2 comes with pre-trained as well as fine-tuned chat models. So what are pre-trained models? These models are not fine-tuned for chat or for question answer. They should be prompted so that expected answer is a natural contribution of the prompt. So if you want to just complete a sentence, then you can use the pre-trained model. But if you want to do question answering or chat with your Llama 2 model, then you should use Llama fine-tuned chat model. So in this tutorial, I will be using fine-tuned chat models because I will be doing chat or question answering with my Llama 2 model. So here in the fine-tuned models, we have 3 different models with 3 different parameters. So Llama 2 with 7 billion parameters, Llama 2 with 13 billion parameters, and Llama 2 with 70 billion parameters. So in this tutorial, I will be using Llama 2 with 7 billion parameters chat model. So if you just go to the Hugging Face, so if I just go to the Hugging Face from here, okay, and you just need to create an account on Hugging Face as well. So if you haven't created your account, you can just go and create your account. So I already have an account on Hugging Face as well. So I will just log in over here. So I've just logged into my account, then I will just go to the settings. So basically this API token will be required so that we can assess the models from the Hugging Face. So if I just go to the models from here, so here you can see that we have the Llama 2 with 7 billion parameters model. So this is the pre-trained model, and this is the Llama 2 7 billion chat model. So I will be using this chat model. This is a fine-tuned model so that we can do question answering or chat with our Llama 2 model. So in this tutorial, I will be using this Llama 2 7 billion chat HF model. Okay. So now we have installed all the packages. So now I will just log into my Hugging Face account, and I will just pass my SS token over here so that I can access models from the Hugging Face. So if I just run this cell, so you should know that you just need to go to the settings from here, and you just need to go to access tokens from here, and you just need to copy this from here, and you just need to paste this token over here, and you just need to click on yes, Y over here. Okay, so login is successful. So if this message appears, then it means login successful. Okay, then I will just go to go below, and in the step number 3, I will import all the required libraries. So here I will be importing Hugging Face pipeline library. So I will just run this cell. So I'm now importing Hugging Face pipeline library. Okay, so now I will also import auto tokenizer. So auto tokenizer is basically responsible for processing text into an array of numbers. So our input text will be converted into an array of numbers using auto tokenizer, and this will be passed as an input to our Llama 2 model. Okay, so I'm just importing warning so that if there is any warning appear, it can be ignored. So we have imported all the required libraries. So let's go further. So in this tutorial, we are using Llama 2 chat model with 7 billion parameters. The basic building block of LangChain is a large language model which take text as input and generate more text. So if I just go over here, so if you just, I told you over here, okay, so you just need to copy this from here and just add this over here. So now we just need to run this cell. So now I'm currently loading the model. Here I'm defining the tokenizer as auto tokenizer, which I've defined already above. So if you just see over here, it's a text generation model. Llama 2 is a text generation model. So I've just defined text generation over here. Here I've just defined the tokenizer over here. And okay, so here I've just I'm using free version of Google Colab. So it comes with free version of Google Colab offers free 15 to 16 GB of GPU RAM. So I will be using this GPU RAM. Okay, so now I will just run this cell. So here I have just defined the input token limit with maximum length over here. So now you can see that I'm just downloading this model over here from Hugging Face. I'm just downloading this Llama 2 model into my Google Colab notebook. So this will take few seconds. So let's wait until it's get downloaded. So now here you can see that we have 15 GB memory, 15 GB GPU card available over here. So we will be using this 15 GB GPU card available here. And this is my disk space, and this is by the system RAM. So all are okay currently. We don't need to anything. It's not anything that we should panic. So that's good. So it's about to download. So this will take 2 more seconds before it is ready. Okay, so now I will just create a Hugging Face pipeline over here. So I have just imported this Hugging Face pipeline library over here. You can see that you can usually use Hugging Face library if you want to run the model from Hugging Face locally. So we generally use Hugging Face library in this case, Okay, so yeah, one step is still pending over here. So let's see until this process completes. So you can see that it's done now. So now I will just create a Hugging Face pipeline over here. I will just, as you can see that it's stored in variable pipeline. So I've just defined over here, and here I've just set a temperature value. 0. So the temperature, what is the temperature value? Temperature value defines how much creative our model can be. So the temperature value is between 0 and 1. So if the temperature value is 0, you can see the details over here. So that if the temperature value is 0, it means the model is very safe. It's not taking any bets. So if the temperature value is 0, it means the model is not creative at all. If the temperature value is 1, it means the model will take risk. The model will be very creative, but it might generate the wrong output. So the temperature value basically adjusts the randomness of the output, how much random our output will be. Okay, so if the temperature value is higher, like as the temperature value varies between 0 to 1, so if the temperature value is 0.7, this will make the output more random. While if the temperature value is low, like 0.2, 0.3, it will make our output not more random, or our output will not be more random, or our output will not be creative, but our output will be more focused and deterministic. But if we set a higher value of temperature like 0.7, 0.8, our output model will be very creative. It might generate the wrong output, but it will be very creative. Okay, but if the temperature value is very low, like 0.1, 0.2, basically the output will not be very creative. Our model will not be taking any bets. Okay, so basically the temperature value adjusts the randomness of the output. So this is all from the temperature value. So let's run this cell. So now we have created a Hugging Face pipeline, and in the pipeline over here, we have defined our model, which is Llama 2 with 7 billion parameters, and we are using the fine-tuned chat model. Okay, so here we have defined the model, and this is in here we have our Llama 2 model, chat model with 7 billion parameters. So now I will just pass an input to my Llama 2 model directly. So the output will be what would be a good name for a company that makes colorful socks. So I am passing this text as an input to my Llama 2 model. What would be a good name for a company that makes colorful socks? So I will just run this, and let's see what output do we get. So here is our output. So here are a few suggestions for a company that makes colorful socks. So here are few name suggestions for a company that makes colorful socks. So it is Hue and Socks, Color Vista, Soulmates, Dive Ventures, The Sock Drawer, Colorful Trace, Soul Stations, Hues and Views. These are multiple names, and there are reasoning are given as well, like why you should choose this name for your company that makes colorful socks. So that's very good. Here, the name of the company is provided, and here the reasoning is also provided. This name plays on the term hues, which refers to the color, and socks, which is the product that the company makes. Okay, so here, Color Vista, this color name conveys the idea of font, vibrant color, and suggest a festive atmosphere. So here we have the names for the company that makes colorful socks. And here we have the reasoning, like why we should choose this name for our company that makes colorful socks. So the next input which I'm passing to my large language model or Llama 2 model is, I want to open a restaurant for Chinese food. Suggest me a fancy name for this. So let's run this. So here we get the names of the restaurant that makes, for example, I just asked a question. I want to open a restaurant for Chinese food. Suggest me a fancy name for this. And here we got different restaurant names for Chinese food. Okay, so here we have Walk This Way, and here we have the reasoning, like why we should choose this as my restaurant name. Okay, a clever play on words that combine wok, a cooking vessel used in Chinese cuisine, with Go This Way suggests a direction or path to delicious Chinese food. Okay, so we have, so it has provided 10 different restaurant names that I can choose for my restaurant that makes Chinese food. Okay, so then we have Chow Mein Palace, okay, a name that refers popular Chinese dish, which also implied a regal and royal atmosphere. So here then we have Sichuan Spice, and then we have Noodle Law. Okay, so here we have the restaurant name, and here we have the reasoning, like why we should choose this as our restaurant name. We have very detailed reasoning provided over here as well. Then we have Egg Fuyong Emporium. So are named that reference a popular Chinese dish while also implying a sense of grandeur and opulence. Okay, and then we have Hot and Sour Heaven, a name that reference one of the five basic flavors in Chinese cuisine. So you can see that here we have all the restaurants name. Okay, and here we have the reasoning. So I've just passed this input that I want to open a restaurant for Chinese food. Suggest me a fancy name for this. And it has provided me the names for my restaurant that serves Chinese food with the reasoning over here as well. Now we will look at the prompt templates. So in the above example I showed you, so we are just passing this input directly to the Llama 2 model as input. So while this is not an ideal case, usually in large language model, we do not pass our input directly to the large language model. So usually we do not pass our input directly to the large language model. It can be any OpenAI model, or it can be any Llama 2 model, or it can be any other open source model as well. So we do not pass the user input directly to our large language model. Okay, so here you can see that we are passing the user input directly to the large language model. Here we are also passing the user input directly to the large language model, but this is not an ideal case. Currently in the above application, we are writing an entire prompt. So you can see that here we are just writing an entire prompt. So you can see that we are writing an entire prompt over here. If you are creating a user-directed application, then this is not an ideal case. LangChain facilitate prompt management and optimizer. So normally when you use an LLM in application, you are not sending the user input directly to the large language model. So that is what I'm saying. In case of if you are using any large language model application, which is built with any open source or closed source model, we do not send the user input directly to the large language model. Here we are just sending the user input directly to our large language model, which is Llama 2. So we normally when you use an LLM in an application, you are not sending user input directly to the large language model. Instead, you need to take the user input and construct a prompt and only send that to the large language model. So what we do is we take the user input in real applications. We take the user input and we just pass this user input to our prompt. Okay, and then we pass that template. We just pass the user input to our template, and then we pass that template to the a large language model. It can be Llama 2 or any other model. So let me show you how we do this. So here I will just import all the required libraries. So for example, I previously have just seen that I want to open a restaurant for Chinese food. Suggest me a fancy name for this. So the user will not be writing this entire prompt, like you can see that. Okay, so user will not be writing the entire prompt. Instead, I will ask the user to just write cuisine, like whether you open a restaurant for Chinese food or Italian food or Mexican food or Indian food or Pakistani food. So I will just ask the user to enter the name of the cuisine. So here the user will just enter the name of the cuisine and will pass the cuisine name over here. I want to open a restaurant, or for example, a user enter the cuisine name as Chinese. So we will just pass the cuisine name Chinese over here. So I want to open a restaurant for Chinese food. Suggest me a fancy name for this. So user will just pass the cuisine name and we then pass that cuisine name to this template, and this template will be passed as an input prompt to the large language model. So if for example over here, we have here the prompt template, and in this prompt template, the user enters. So this is what user has entered. So user enters Italian. So this Italian will be added. This Italian is the cuisine name. So this cuisine name will be added over here, which is Italian, and this complete prompt will be passed to the large language model. So let me just show you. So user has entered only the cuisine name, which is Italian, and we are just passing this entire prompt to the large language model. So our entire prompt will be, I want to open a restaurant for Italian food. Suggest me a fancy name for this. So this complete input prompt is being passed to the Llama 2 model. So we have just taken the cuisine name from the user. So user have just entered cuisine name as Italian. And then we have just passed this cuisine name over this template over here. And then we are just passing this complete template to the our Llama to our Llama 2 model. Okay, so let's take example number 2. So here you can see over here, we can see that we have defined the prompt template over here. And here you can see that I am asking user to just enter the book name. So if the user enters the book name as Alchemist, we will pass this book name into this template over here. So please provide me concise summary of the book. And here we get the book template as book name as Alchemist. Here we get the book name as Alchemist. And this complete template or this complete input prompt will be passed to my Llama 2 model. So the input prompt that I will pass to the Llama 2 model will be, please provide me a concise summary of the book Alchemist. So the user has only entered Alchemist while we are just passing this complete input prompt to the Llama 2 model. So next we have chain. So what to execute? So now you can see that here we have created prompt template over here and one prompt template over here. So we have created 2 prompt template. So to execute each of the prompt template, we require chain. Okay. So to execute each of the prompt template, we require a chain. So here you can see that chains combine LLM and prompt template in multi-step workflow. So in simple words, let me show you. Let me explain you. For example, if I want to execute this prompt template, I will require an LLM chain. So if I want to execute this prompt template, I will require an LLM chain. So if we have 2 prompt templates, we require 2 LLM chains. Okay. And for example, then we have 2 LLM chains. To combine these 2 LLM chains, we also require a chain as well. Okay. So chains combine large language model and prompt templates in multi workflow. Okay. So LLM chain is responsible to execute prompt template. For every prompt template, we specifically have an LLM chain. Okay. So for example, here I've just created a prompt template. Please provide me concise summary of the book. And here the user will pass the book name. Okay. So to execute this prompt template, I will require LLM chain, which I've created over here. So LLM chain will take the input of the large language model. So you know that we have defined the large language model above over here. So here you can see that we have defined our large language model as hugging face pipeline, and the pipeline I have the Meta Llama 2 model with 7 billion parameters, and it is a chat model. Okay. So here we were. So here we were. So here I have just created an LLM chain. In the LLM chain, I have just passing my Llama 2 model as the input. And we have the prompt template. We are passing this prompt template as the input, and verbose is equal to true. So it will give me a more detailed answer. And here the user is just passing the input Alchemist. So the user is just passing the Alchemist as the input over here. So here the input will be Alchemist only. Okay. So here we have the complete input. Provide me a concise summary of the book Alchemist. So this will be passed as an input. So this complete template will be passed as an input to our Llama 2 model. So here the user will be just input the Alchemist over here. So when we just run this chain, so let me just show you. So user has just input the book name Alchemist, and we are just passing this complete template to our Llama 2 model. So this complete template will be provide me a concise summary of the book Alchemist. So this complete input template or input prompt will be passed to the Llama 2 model. So you can see that this book is Alchemist is written by Paulo Coelho. So this book is a must-read book for anyone looking to explore the mysteries of existence and find their personal ledger. So here is the summary of the concise summary of The Alchemist by Paulo Coelho. The Alchemist is a fable about a young shepherd named Santiago, which sets out on a journey to fulfill his personal ledger and find his treasure. Okay. Along the way, he meets various characters who teach him valuable life lessons about the power of belief, perseverance, and listening to one's heart. Okay, so here you can see the detailed summary of the book Alchemist we have. So the user has only entered the name Alchemist book name and just passed this book name over here in this template, and this complete template will be passed to our Llama 2 model as an input. So you can see that provide me a provide me a concise summary of the book Alchemist. So let's see another example. So here the user will just input the cuisine name like Italian, Mexican. So here just input Italian, and then this complete template, this cuisine name will be passed to this template over here, and we just pass this complete template as an input to our Llama 2 model. So you can see that this complete input template is passed as an input to our Llama 2 model. And let's see what name. So previously you can see that the user is passing this complete input in the prompt, like I want to open a restaurant for Chinese food, suggest me a fancy name for this. So this complete input is being passed by the user to the Llama 2 model. So now we have, and this, we are just asking the user to enter the cuisine name. And when the user enter the cuisine name like Chinese, Italian, we just pass this cuisine name to our template, which we have already written. And then we pass that template to the Llama 2 model. So user just enter the cuisine name, and we enter the cuisine name into this template, and then we pass this template to the Llama 2 model. So you can see that this, I want to open a restaurant for Italian food, suggest me a fancy name for this. And here you can find the answer. So we have the name Bella Vita. So here we have the reasoning like why we can choose this name. This name means beautiful life in Italian and conveys a sense of joy and well-being. Then we have La Strada. This name means the street in Italian and evokes the feeling of being on a bustling Italian street. And then we have Pasta, Pazia. This name combines Italian word pasta, Italian words for pasta and craze. And then we have Biscotto. This name means biscuit in Italian, which would be a great fit for a restaurant that serves a variety of Italian desserts. So in this way, we have 10 different names for the restaurants that serves Italian food. So now you can see over here, we have created a chain over here. We have created a chain over here. So for each prompt template, we require an LangChain. So if we have, now you can say that we have two LangChains, okay? So you might ask, think over here, can we combine multiple prompt templates? So you can see we have two prompt templates. One is this one, and the other one is this. So you can say first one, this is this prompt template. Then we have the second prompt template, which is this. Okay, so can we combine these two prompt templates? So for example, the output from this prompt template will be passed as an input to this prompt template. Okay. Can we combine multiple prompt templates? Yes, we can combine multiple prompt templates. So to combine the multiple prompt templates, we also require chain. So I told you that to execute this prompt template, we require an LangChain. And if you just want to combine the two prompt templates, we also require an LangChain. We also require a sequential chain for this as well. Okay. So the output from the first prompt template is passed to the next prompt template as input. So, okay, so to combine multiple prompt templates, or we require simple sequential chain. Okay, so you can see here we have defined the first prompt template. I want to open a restaurant for cuisine that will be passed by the user. So open a restaurant for Chinese food, for example, suggest me a fancy name for this. So here that we get the output as restaurant name. So from the output from here will be the restaurant name, and this restaurant name will be passed as an input to our next prompt template, which is this one. Okay. And then now we have two prompt templates. So, and we have for each of the prompt template, I told you that we have a LangChain. So this is the LangChain for this prompt template, and this is the LangChain for this prompt template. So now to combine these two chains, we require simple sequential chain. So here you can see that I've just combined these two chains, restaurant name chain and restaurant menu items chain, using simple sequential chain. So just run this from here. So now using simple sequential chain, I'm just combining these two chains, restaurant name chain and restaurant menu items chain. So the output from here, we will get the output as restaurant name, and this restaurant name will be passed and input to this prompt template. So here we are saying that you are provided with a list of restaurant names. So you can see that uh, I'm just asking for the restaurant name over here. So we get a list of restaurant names. I told you that. Here I'm just asking, I want to open a restaurant for cuisine, Chinese, maybe. Suggest me a fancy name for this. So here you can see that we are getting a list of restaurant names. Okay, so here I'm just saying you are provided with a lot of restaurant name. Just pick the first restaurant name and suggest some menu items. Okay, so you can see that we have tens of restaurant names. So I'm asking that just pick the first restaurant name and suggest some menu items. So there we are not getting the expected answer. So I'll just write for the. So let's update this prompt a bit and let's run this. We have just updated this. I have just kept it same. I want to open a restaurant for cuisine as the input by the user and food. Suggest me a fancy name for this. And I have just updated this. You are provided with a lot of restaurant names. Just pick the first restaurant name and suggest some menu items for the restaurant. So let's execute this. I hope it will work fine. So this might take few seconds before it gets executed. So here we have the output. So we have just Italian cuisine. So here is the input by the user, Italian. So I want to open a restaurant for Italian food. So just me a fancy name for this. So here we have bruschetta and we have chicken parmesan. So here we have the reasoning like why we should offer this food. Okay. And here we have the recipe over here available as well. And then we also have garlic knots, fresh garlic knot dessert with olive oil. And here we have the reasoning. Along with this, we have pretrained miso. So this is another dish, or I think coffee stove, another thing. So these are different outputs. So what here we are using simple sequential chain. So what is the issue with simple sequential is that we only get the output from this last prompt template. So with simple sequential chain, we do not get the output from the other prompt template. So using simple sequential chain, we only get the output from the last prompt template. So this is our last prompt template, and we are getting the output of this last prompt template. We are not getting the output of this prompt template, which is I want to open a restaurant for Italian food. Suggest me a fancy name for this. So we are not getting the output from this prompt template. We are only getting the output of this prompt template, which is you are provided with a lot of restaurant name. Just pick the first restaurant name and send just some menu items for the restaurant. So we are only getting the output for this prompt template. We are not getting the output for this prompt template. To solve this error, we can use sequential chain. Okay. So this is the issue with simple sequential chain. It only shows last input or prompt template information. To show the entire information, I will use sequential chain. So we'll just run this cell from here. And then we will just run this. And here you can see that we are using sequential chain and cuisine is Italian. And the input will be, I want to open a restaurant for here you can see the cuisine is Italian. So Italian food, this is the input by user. Suggest me a fancy name for this. Please provide me one restaurant name. So I'm just saying that although you get the list of restaurant names, so yeah, you can see over here, it provides us a list of restaurant names. You can see 10 different. So I'm just saying that please provide me one restaurant name. Okay. And then I will just pass this restaurant name. So here I'm just getting the output from this prompt template. The output from this prompt template will be restaurant name. And this restaurant name, the output of this prompt template is passed as an input to this next prompt template, which is suggest some menu items for this, which is the restaurant name we get from here. And here you can see that now we are just getting the restaurant name as well. We are getting the restaurant name as well, Vita. Okay, and the reasoning over here as well, but we are not getting the menu items. So let me just update this prompt. So suggest menu items for the restaurant. Okay. So let's execute this and let's see what we get in the output. Here we have the restaurant name as Bella Vita, and here we have the menu items. So we have just updated the prompt template and we get the menu items over here. So you can see over here we have Briskita as the menu item. We have Insalta Capers as the menu item. We have Polenta fries as the menu item, and here we have the uh, dish and the reasoning provided over here as well. And we have the lasagna bolognese as the menu item, which you can see over here. We have the pasta as the menu items. You can see over here. These are in the bullet points. So, and we have the chicken parmesan as the menu item. We have the vitello milanese as the menu item. So you can see that we have a lot of menu items over here. And you can also see if you choose the cuisine as Pakistani, and here you can get the restaurant name as Spice Route, and here you can get a lot of menu items like chicken biryani, beef halim, fish tikka, and faluda, samosas, and gulab jamun. So there are a lot of menu items, and naan bread. So there are a lot of menu items provided over here as well, and this is the restaurant name like Spice Route. So this is all from the chains. You have used chatbot applications like ChatGPT, you might have noticed that it remembers the past information. So if we create our own LLM application, like ChatGPT is an LLM application. So if we create our own LLM application, let's see how we can add the memory so that it can remember the past information. So let's see how we can add memory to our own LLM application. So first of all, this is same thing, like I have just created a prompt template and this is the LangChain. Okay. So let me just show you. So let's see how does it works. So here the input is colorful stocks, which we are passing over here. So I'm just writing, so just a name for a company that makes, and the products I'm just passing colorful stocks. So, okay. So here we have this, no, I don't think it's, let me just update this. What is a good name for a company that makes? Okay, so let's pass this as an input. Okay. So here I'm just passing the user as a user. I'm just passing colorful socks, and this colorful socks will be added over here in this template. And let's see what output do we get from here. So this might take few seconds before we have the output. So here you can see that here are some suggestions for a name for a company that makes colorful socks. So you might notice that this is very important that you should write the prompt template that you should get the expected answer from the large language model, which is over here, Llama 2. Like previously I was writing, suggest me a good name for a company that makes colorful socks, but I was not getting the correct answer. So now I've just updated my prompt template with what is a good name for a company that makes colorful socks. Okay, so here I'm now just getting the answer. So you can see that this company name is Soulmate, Hue and Cry Socks, and here the reasoning is also provided, like why you should choose this name. This name plays on the idea of socks being a pair as well as the idea of being a mate or a companion, soulmates. And the other name is Hue and Cry Socks. This name incorporates the idea of color and creating a first, which is perfect for a company that specializes in colorful socks. Rainbow Toes, Happy Toes Socks, Socks are Pop Socks. So there we have we have the names, and here we also have the reasoning. So we have 10 different names for a company that makes colorful socks, and we have the reasoning also provided over here as well. And if I just write security cameras, so now I have the input. What is a good name for a company that makes security cameras? So let's update this prompt. Like, let me just show you. If I just update this prompt over here, yes, good name for a company that makes. Okay, so let me just write this over here as well. So, okay, so let's execute this first. I think we have already imported these packages. We don't need to write this again and again. So let's run this out and let's see what does we get over here. Okay. So I need please suggest some good names for a company. Not getting the correct answer. No, I have just updated this prompt template with what would be a good name for a company that makes, and here I've just passed security cameras as the input, and we can see over here we have got Vision Pro, Secure Sight, Stand Tech, Watchful Eye, Defend Tech. So and here the reasoning is provided as well why we should choose the name. So you can see that I have updated my prompt template multiple times before I get this correct answer. Okay. So if I just check the memory, whether we have some history stored, so you can see none. We don't have anything stored in our memory. So now let's see how we can add the memory. So to add the memory, we will use conversation buffer memory. So here I'm just importing from LangChain.memory, import conversation buffer memory. And here, let me just add this prompt template over here as well. So, okay, and let me add this over here. Yes. Oh, why should we add over here? Let me add over here. Okay, and if I'm just searching for the colorful socks, so let me just update this prompt template with what is a good name for. Okay, so let's execute this and let me show you how we can save our chat history or how we can attach a memory to remember all our previous conversations. So I'm now just attaching a memory so that it my large language model can remember all the previous conversation as well. Okay, so here you can see that we have soulmates, hue hues, baby socks, and here we have the reasoning. So let's see for some other thing. Let's do it for the drone cameras. Okay, so let's run this and let's see what does we get over here. So here you can see that aerial eye, drone vision, skycraft, light cam, rise above. So these are the names of the company that makes drones cameras. Okay, so these are the few good names for a company that if you are making drone cameras, you can just choose one of these names as well. Okay, so let me just print the memory buffer now. So now you can see that first question I asked colorful socks. Okay, and it gives me answer soulmate, hue hues, baby socks, speed first. And the second question I asked about drone cameras. This is my human and this is the human. Colorful socks first time I asked and the second time I was asked as drone cameras. Okay. And here I'm just getting the answer aerial eye, drone vision, skycraft, flight cam, and rise above. So here I'm just getting the names. So these are all the company names and you can see that we have stored the previous chat history. Okay. So we have attached a memory to all our previous conversation and like first time I asked colorful socks and second time I asked about drone cameras and we have saved our previous conversation. Okay, so conversation buffer memory. So currently here I'm using conversation buffer memory. You can see that. So there is a drawback of conversation buffer memory. So conversation buffer memory goes growing endlessly. Like if I'm doing if I have 100 to 200 chats, so all these chats will be saved in my conversation buffer memory and it goes endlessly. But this is not an ideal case. If I just want my conversation buffer memory to remember last 5 conversation or last 10 or 20 conversation. It should remember last 5, 10 or 20 conversation. It should not grow endlessly and remember my previous thousands of conversations. So for this, I will first import conversation chain from here. And here I've just initialized my Llama 2 model over here with 7 billion parameters. And I'm using the chat model, fine-tune model over here. So currently you can see that it's empty. The history is empty. So if I just ask the first question to my Llama 2 model, who won the first World Cup? Okay. So here we have the answer. Yes, the first Cricket World Cup was held in 1975 in England and Wales. The West Indies team won the tournament, defeating Australia in the final of 17 margin. So West Indies won that. And if I ask how much is 5 plus 5, and let me ask other question over here as well. So as simple question, 5 plus 5 is equal to 10. Smiling, that's good. Who was the captain of the winning team? So I'm not passing that who was the captain of the winning team. So you can see that. Great question. The captain of the winning team in the first Cricket World Cup was Clive Lloyd of the West Indies. He led to the team to the victory in 1975 tournament. So you can see that now we have added the memory. So our large language model remembers the previous conversation. Okay. So you can see that first I just asked who won the first Cricket World Cup. So it told me that West Indies won the Cricket World Cup and it was a match between 1975 England. It was held in England and West Indies won that World Cup by defeating Australia. Okay. So West Indies won the tournament defeating Australia. You can see over here. Okay. Now I don't pass who was the captain of the winning team. So I don't ask who was the captain of the winning team who won World Cup in 2012 or 2018. So I don't pass the year. But as I have asked the previous question, who won the first Cricket World Cup? So it has saved that chat history in the memory. So it has given me the answer. The captain of the winning team in the first Cricket World Cup was Clive Lloyd. Okay, so all the chat history was saved in our large language model, and it has given me the answer as from the chat history, and it is Clive Lloyd. Okay, and if I just print the chat history, so you can see that this is the question, and this is the AI response. So now you can see that we have added the memory and we are able to save our previous conversation. So using conversation buffer memory, we are able to save all our previous conversation. But there is seriously a drawback of this. So if I just want, so now here I'm just adding conversation buffer window memory. Okay. So using conversation buffer window memory, I can define K term. So conversation buffer window memory means how many previous conversation I want to save. So if I just define K is equal to 1, it will remember only one last conversation. So if I just execute it and ask the same question, who won the first Cricket World Cup? And I let me run the next cell as well. Well, you can see over here, I have defined K is equal to 1. So it remember only one previous conversation. So who won the first Cricket World Cup? It told me that West Indies won the World Cup in 1975, defeating Australia. And I just asked next question, how much is 5 plus 5? So it tell me 10. So next I asked who was the captain of the winning team? So it says, oh, that is a great question. I'm afraid I don't have access to real-time information, so I can't tell you. So this is the difference. So now it only remembered just one previous conversation. Okay, so it only remember last conversation. So I'm fine K is equal to 1. So it only remember the last conversation. So it does not remember that I just asked the question one conversation back who won the first Cricket World Cup. So it is unable to answer me the answer over here. While here you can see that I have not defined the K term. So here you can see that the memory grows endlessly. And here when I asked who was the captain of the winning team, so it told me that Clive Lloyd of the West Indies was the captain of the winning team, because here we have saved the conversation. So here we have defined the K term. So using this K term, you can save a previous 10 conversation, you can save the previous 5 conversation. So if I just K is equal to 5 and just run this now. So now I'm just saving my previous 5 conversation. So let's see what result do we get over here. Now you can see over here, I was just asking the same question, who was the captain of the winning team? And I have set the K is equal to 5. So it remember previous 5 conversations. So it has given me the answer. The captain of the winning team during 1975 World Cup was Clive Lord. So it has given me now the correct answer. Previously, you can see that it was unable to answer because I have set K is equal to 1 and it was unable to remember the chat conversation. So now it remembered previous 5 conversation. So it is now able to answer. Now we will see how we can extract the data from the PDF file using LangChain. We can also extract the data from text file as well as CSV files as well. So in this video tutorial, I will just show you how you can extract the data from PDF file using LangChain. Although if you just see the LangChain documentation, you will see that we can extract the data from CSV file, .txt file, and in the .md file format as well. So now I will just upload a PDF file over here. Okay, so I've just uploaded this PDF file. You can just directly download any PDF file as well. So just copy path from here and just add this path over here. Okay, so now I will just install the PyPDF package. Okay. Okay, I should have installed this at the start. So let me just click over here. Okay. And let me now install this package. So this might take few seconds before it is ready. So now you can see that it's installing the package. So now you can see the package installed. So I will just read the data from the PDF file and I will extract the data from it. So now I will just extract the data from it. So using PyPDF loader, I'm just reading the data from this PDF file and extracting the content from it. So this is all the data we have in the PDF file. So using LangChain document loader, you can extract the data from the CSV file as well, in the .md file, in the .txt file as well as you can also extract the data from the JSON file as well. So all these details are provided in the LangChain documentation. Do check it out as well. So that's all from this video tutorial. Thank you for watching it.